Hello everyone, welcome to my physics class. Today we discuss about the force exerted by liquid. In the previous video lecture we discussed about force, moment of force and pressure. In today's module we discuss about pressure exerted by liquid, pressure exerted by gas, manometer, applications of pressure exerted by liquid. We will discuss all these things one by one. First of all, we discuss about pressure exerted by liquid. We know that liquid don't have any fixed shape. It takes the shape of the container into which it is kept. Thus, liquid have no any specific area as they take the shape of the container they are kept in. The depth of the liquid also varies according to the shape of the container. So, height or length of the column liquid varies depending upon the shape and size of the container. To find out if a liquid can exert pressure, we need a glass tube open at both ends, a balloon, and some water. This is a glass tube. One end is kept open and the another end is covered with balloon and the glass tube is filled with water. Take a glass tube that is open at both ends. Initially it is open at both ends. Fix a rubber balloon at one end of the tube. This end of the tube is fixed with a rubber balloon and the upper end of the glass tube is kept open. Hold the glass tube with the balloon facing downward. Now we hold the glass tube in such a manner that the balloon facing downwards and pour water in it. As you pour water into the tube, the balloon bulges out. Means the shape of the balloon gradually increases. Size of the balloon gradually increases. The balloon bulges out because of the pressure exerted by the liquid in the test tube. When the column of water increases, the liquid exerts pressure on the balloon, and as a result of which the size of the balloon gradually increases. This is the size of the balloon. When the liquid column increases, the size of the balloon becomes larger. As more and more liquid is poured in the test tube, the balloon keeps bulging out and as the pressure exerted by the liquid increases. Now, liquid exerts pressure not only at the base of the container. Liquid doesn't exert pressure on the base of the container, but also on its sides. Also, the pressure exerted by liquid increases with the depth of the liquid. Let us perform an activity to understand this concept. To show that the pressure of a liquid increases with the depth of the liquid, we need a plastic container, a knife or any other sharp object, and a clear sticky pipe. Take the plastic container and make 3 holes. These are the 3 holes in the plastic container at different heights. Close the holes with clear sticky tape. Now these holes are closed by clear sticky tape. Pour some water into the container and remove the sticky tapes from all the 3 holes. What will you observe? You will observe that water from the topmost hole comes out with the least force. The water from the topmost hole comes out with the least force and falls at the least distance from the container. The water from the lowest hole, this is the lowest hole, comes out with greatest force and falls at maximum distance from the container. So you conclude that liquid exerts pressures not only at its base but also on its sides, because these holes are made on the sides of the glass container. This also proves that the pressure exerted by a liquid increases with the depth of the liquid. When the depth of the liquid increases, the pressure exerted by liquid also increases. Since the pressure of liquid increases with the depth, deep sea divers wear a special suit. These special suits protect them from the increasing water pressure. Now we discuss about manometer, which is a device which is used to measure the pressure of liquids. It is based on the working principle which states that the pressure at any point in a liquid at rest is same in all direction, which is also known as hydrostatic equilibrium. It comprises of a U-shaped glass tube. This is a U-shaped glass tube filled with mercury open at both ends. Both ends are initially open. This tube is mounted on a wooden frame. It is mounted upon a wooden frame with a scale. This is the scale attached in the middle of the U-tube. One end of the tube is attached to a rubber tube. One end, this is attached to the rubber tube. This is the rubber tube. Attached to a rubber tube, the piston funnel with a thin membrane is at the closing edge of the rubber tube. And in the rubber tube, this is the U-shaped rubber tube. The one end of the rubber tube is attached with the piston funnel, and the other end of the U-tube is left free. This is the other end. This is one end, and this is another end. One end is left free, and another end is attached with piston funnel. Initially, the level of mercury in both the arms of the U-tube is same. These are the both arms of the U-tube. In both the arms, the level of mercury initially same. To measure the pressure of the liquid, piston funnel is inserted in it. This is a container containing water. When the piston funnel is entered into the water, into the liquid, the level of liquid in two arms of the manometer changes. The difference between the level of liquid column in two arms can be measured with the help of the scale attached to the U-tube. The more the difference in height of the liquid column, the more will be the pressure exerted. The pressure exerted can be calculated as P is equal to H rho G, where H difference height between the level of liquid column in two arms, rho stands for density of the liquid, G is the acceleration due to gravity. Characteristics of pressure exerted by liquid and demonstrated it using a manometer. Now let's perform an activity to demonstrate the pressure inside the liquid increases with depth using manometer. A U-tube manometer and a large beaker filled with 3/4 water. This is a U-tube manometer, and this is a container which is filled with water 3/4 of its capacity. Immerse the piston funnel of the thermometer of the manometer tube slowly in water inside the beaker. See, the piston funnel is attached. Piston funnel is attached to the one of the two ends of the manometer. Now, the level of water in the limbs of the manometer while now insert the funnel into the water and observe the level of height of water in the limbs of the manometer. You will observe that when the piston funnel enters into the water, the level of water in one arm decreases and in other arm increases. As when the depth of the water increases, the level of water in one end goes increasing and in another end goes decreasing. When the funnel was held steady at a certain depth, the water level in the two arms of the manometer becomes stable. So, as the difference in water level in two arms of manometer increases, it indicates that liquid pressure increases with increasing the depth in the liquid. If the depth of the liquid increases, the liquid exerts more pressure. Now, application of liquid pressure. The walls of the dams of a thicker The walls of the dam are thicker at the bottom than at its top. This is because of the fact that pressure exerted by the liquid increases with depth. So the bottom walls of the dams are thicker because at the bottom of the dam the depth of the liquid is or the water is greater, so it exerts greater pressure at the bottom. The scuba diver wears a protective suit with withstand high liquid pressure. Hydraulic jack and lifts are based on the principle of transmission of liquid pressure. These are the applications of liquid pressure. Now pressure exerted by gas. Just like solid and liquids, air also exerts pressure. When we blow air into a balloon, the balloon inflates. The size and shape of the balloon increases. Further, if we keep inflating the balloon, after a certain point it bursts, it cracks. This happens because air exerts pressure on the walls of the balloon. This is why the balloon bursts after a certain point. The gases exert pressure in all directions because the molecules of gases move in all possible directions. We know that the molecules of the gases are very loosely bound with each other. This is why they can move in all possible directions available to them. So the gas exert pressure in all directions. The atmosphere around us, which is a mixture of various gases, also exert pressure on all objects. The pressure exerted by the weights of atmosphere on an object is called atmospheric pressure. The pressure exerted by the weight of the atmosphere on an object is called atmospheric pressure. The atmospheric pressure is never felt by us because blood exerts pressure inside our body. We know that when the heart pumps blood to the several parts of our body, the blood also exerts pressure inside our body. This pressure counterbalances the atmospheric pressure. This is the reason why we don't get crushed by the immense pressure of the atmosphere exerted on our body. To show that atmospheric pressure, the atmosphere exerted pressure, we need a glass tumbler, water and cardboard sheet. Take a glass tumbler, fill it with water. In this gas tumbler, fill the glass tumbler with water. Place the cardboard sheet over the mouth of the tumbler. Now place your hand over the cardboard and quickly invert the tumbler. Now invert the tumbler quickly. Now slowly remove your hand that supports the cardboard sheet. You observe that cardboard sheet does not fall and prevents the water in the tumbler from falling. Why this happens? What is the reason behind such kind of miracle? The cardboard sheet doesn't fall because the atmosphere exerts pressure on the cardboard sheet. The atmosphere exerts pressure on the cardboard sheet in upward direction, which is more than the pressure exerted by the liquid on the cardboard. The pressure exerted by the liquid on the cardboard is downward, and the atmospheric pressure exerted on the cardboard is upward. The atmospheric pressure is more than the pressure exerted by liquid on the cardboard. Thus the atmospheric pressure prevents the cardboard from falling. Atmospheric pressure has some uses too. It is the reason behind some of the experience in our daily life. One of the uses of air pressure is use of straw for drinking. Most of the common experience while drinking means while drinking cold drinks, we use a straw and we draw the cold drinks into our mouth using air pressure. Let us understand how. While drinking a liquid using a straw, we suck the air present inside the straw. First we suck the air. When the air inside the straw is sucked, the pressure decreases below the atmospheric pressure. The atmospheric pressure causes the liquid to rise in the straw and we are able to drink it. The atmospheric pressure at a place depends on its altitude. The pressure reduces as we go to the places at higher altitude. As you go higher up the mountains, you will find that your ears pop. This happens because the air pressure around your ear decreases. It means that air pressure decreases with increase in altitude, causing an imbalance between the pressure inside and outside your body. It causes an imbalance between the blood pressure inside your body and air pressure outside your body. This is why we hear a pop sound in our ear. Effect of atmospheric pressure. Mountaineers often suffer from nosebleed at high altitudes because the pressure exerted by the blood in the body becomes higher than the pressure exerted by the atmosphere outside the body. The higher blood pressure, when the pressure exerted by the blood in the body becomes higher than the atmospheric pressure, the nose bleeds at high altitude. Rubber air suckers used as hangers and pressed onto the surface of almirah on wall or walls where we want them to stick. On pressing them, the air inside gets removed and the atmospheric pressure from the surrounding keeps it stuck to the wall of the almirah. Astronauts wear a special spacesuit to maintain a normal atmospheric pressure for their bodies as there is no atmosphere in the space. So this is all about the chapter force and pressure. We discussed about the pressure, movement of force, pressure, air, pressure exerted by liquid, pressure exerted by gas, and the various applications of the pressures exerted by liquid and the atmospheric pressure. So with this completes your chapter 3, force and pressure. Thank you so much.